Hi, welcome to Dr. Raz the Baking Chemist. Thank you for watching this video. So today's topic is all about equilibrium, but in particular about equilibrium constant. It's a year 1 topic, which of course year 2s will also need. It's a 9-marker question. And remember, at the end of this video, I will tell you 4 steps how to get these questions absolutely perfect. Let's see how easy I can make it. Okay, so this question is one of the exam questions. You'll notice that these exam questions obviously some of them are from previous syllabus. Yeah, the new syllabus, you wouldn't see these part questions necessarily. The new syllabus is a lot more difficult, and what that means by difficult is that they'll give you the full question in one paragraph above, and they'll say, right, work everything out. So they won't lead you through. So just be careful, okay? Obviously, I will use the current syllabus where I can, but previous syllabus don't ignore, because it's a very good revision aid. Okay, let's do this. So this question, KC calculations, tetrafluoroethane, C2F4 is obtained from chlorodifluoromethane. Okay, according to the equation. So there's the equation, there's the equilibrium arrow. Oh, they've given us enthalpy, so there's bound to be a question about that. So enthalpy, forward reaction enthalpy is plus, so it's an endothermic, plus 128, remember, this is what I'm thinking about, plus 128 kilojoules per mole, so it's an endothermic that way, so it must be exothermic that way, just saying. Right, a 1 mole sample of CaCl2 is placed in a container of volume 18.5 decimeters cubed, okay, and heated, right, a 1 mole sample. When equilibrium is reached, the mixture contains, so at equilibrium, the mixture contains 0.2 molar, or not molar, don't make that mistake, that's concentration, this is moles, 0.2 moles of CHClF2. Calculate the number of moles of C2F4, so it's that, and the number of moles of HCl present at equilibrium. Okay, so a number of those, so they're giving you a space, yeah, for each of them. Okay, so whenever I'm talking about equilibrium and I'm trying to work out Kc and moles at equilibrium, I use what I call the ICE method. Okay, so let me show you what the ICE method is. So let me write down the actual equation first. So it's 2CHClF2, and of course equilibrium arrow, reversible arrow, C2F. I'm deliberately trying to write big, but I'm trying to anyway. Okay, so that's a gas, and that's a gas. Okay, right. So what I use is, as I say, the ICE method. The ICE method is as follows. So what I do is I write down I, C, and E. I, initial. C is a change, and E is the equilibrium. Okay, so initial, what moles have we been given initially? It's at the start, and they said a 1 mole sample is placed in a container, right? So that means they must have, and 1 mole sample of what? 1 mole sample of, so chlorodifluoromethane. Okay, so that is 1 molar. I keep saying molar, mole, 1 mole. Okay, it's placed in a container, right? When equilibrium is reached, right? So that's the only thing we know, okay, about this. Obviously, they're only starting with that. That means initially, this must be 0 moles, and this must be 0 moles, right? Now, at equilibrium, they've told me, when equilibrium is reached, a mixture contains 0.2 moles of chlorodifluoromethane, okay? So it contains 0.2 moles. So that means at equilibrium, it contains 0.2 moles. So that means, what's the change? What's changed from there to there? Well, we have what's decomposed or changed is 1, take away 0.2 is 0.8. So that means 0.8 has been reduced. Okay. Now what you do is you look at the ratios of moles. All right. So I know that if 2 moles of this decomposing gives you 2 moles of this. 2 moles of this decomposing gives you 1 mole of that. So if there's 0.8 moles decomposed, so that means I must have got 0.8 moles of this, and it must have increased by 0.8 moles, isn't it? Because it was 0 initially. And of course, this is decomposed by half of that. Okay, so 2 moles gives you 1 mole, therefore, if 0.8 moles have been decomposed or used up, then therefore, I must have obtained half of that, which is 0.4. And of course, you must have added, remember, because this becomes that, so it's added that. So that means at equilibrium, how many moles of tetrafluoroethene do I have? Well, I must have 0 plus 0.4 is 0.4 moles. And how much of the hydrogen chloride do I have? Well, 0 plus 0.8 is 0.8 moles. So the answer to that question is tetrafluoroethene is 0.4 moles, and number of moles of HCl is 0.8 moles. So there you have your answer. Okay, and that's a simple 2 marks, probably 1 and 2. Okay, next question. Write an expression for Kc for the equilibrium. If you can't write an expression for Kc, why? Right? Go back and learn. Right? It's simple, products over reactants, but concentrations this time. Remember, here we're talking about moles. Okay, so I'm just going to answer that question. So part 2, expression. Right? So Kc of this reaction is concentration of the products over the concentration of the reactants. All right, and this time it is concentrations, not moles. All right, so here we go. So concentration of the product. So one of the product is C2F4 and multiplied by the other product, which is HCl. Okay, now you should know that equilibrium constant. So when you're talking about equilibrium constant, it's not just the concentration, it's to the power of the balancing number, the coefficient. Okay, so in other words, this is to the power of 2. I did not put the power of anything here because the coefficient is just 1, so it's to the power of 1. And of course, divided by the reactants. So concentration of the reactants, so CHClF2, and to the power of the coefficient, which is 2, so squared. And that is your expression for Kc for the equilibrium. And of course, these are concentrations at equilibrium. You can write EQM here, EQM, but it's understood. So often people miss it out. It's understood. You're not going to lose marks because of that. So anyway, so that's the answer to part 2. All right. Next part, 3. Calculate a value for Kc and give its unit. So now we're going to work out the actual value. Okay. So this is where this volume comes in. That means we can work out the concentrations. We've got moles at equilibrium, but we need to work out concentrations. And because they've given us the volume, we can work out the concentration. And remember, it's in one container. It's not as if this is in different volume, this is a different volume. This is all in one place in a container, right? So all I need to do is to work out the concentration is, and I'm going to put it down, is C2F4 is, how many moles is it? 0.4. To work out concentration, what do? You work out, you divide it by the volume in decimeters cubed, which is already decimeters cubed, so this is 18.5. Now, I'm going to say something about these square brackets in a second, but let me just write this down. Next one is HCl, which is 0.8 moles divided by the volume, same volume, and of course, remembering that this is squared. And of course, divide that by the concentration of that, which is 0.2 at equilibrium, 0.2 divided by, again, same volume, but remembering also to put squared there. Okay, now square brackets in chemistry, square brackets represents concentration. Okay, you can't do round brackets here, but here, because you're putting in the numbers, yeah, you're actually putting the actual concentration, you don't have to put square brackets. Okay, this square bracket shows me, or shows the examiner, that you mean concentration of HCl, not just moles, right? Here you're showing me the actual working out the concentration, so you don't need to show me with the square brackets. Okay, you can use the round brackets. All right, so anyway, so that's that, and all now you need to do is work it out. All right, so that equals 2.16 times 10 to the minus 2 times by 1.87 times by 10 to the minus 3 divided by 1.17 times 10 to the minus 4. Now, if you can do all of that on the calculator, if you know how to use brackets and you're absolutely confident, fine, do it on the calculator. But you know something, I tend to sort of show each step, okay? But anyway, if you're absolutely confident about using brackets, to use it. Otherwise show steps, okay? And now, if you work that out, that comes to 0.345, okay, kc, okay? Don't know the units yet. Now, 0.345. Why have I put 0.345? Well, when I work this out, what does it come to? It comes to a lot more than 0.345. It comes to 0.3452 and blah blah blah. Yeah, it continues. Okay. The question is, how many? Remember significant figures? Watch my video. I keep talking to you about significant figures. Well, how many significant figures should I put? I don't think in the question they've mentioned how many significant figures. Okay, but you got to give an appropriate significant figure. So I'm looking in the question now. Any values in the question? Look, 2 sig fig there, 2 sig fig there, 3 sig fig there, 3 sig fig there. So 3, 2, okay, 2 sig fig or 3 sig fig. I'm probably going to put just 3 sig fig. Yeah. But the minimum you need to put is 2 sig fig. Any less, and you lose marks. Okay, so I'm going to put 3 sig fig. What's the units? Well, that's the next part. Okay, so I need to work out now the units in equilibria for Kc. Units change, so you've got to work out for every reaction. Okay, so the units are, again, if you don't, I think you should know how to work out units. If you don't, you just use that equation, but instead of putting numbers in, you just put units in. Okay, so what I'm going to do is I'm going to work it here. So Kc units, okay, is that's units. Obviously, units for concentration is moles per decimeters cubed. So I'm going to put moles per decimeters cubed. There's no power there, so just leave it like that. Multiply by moles per decimeters cubed, and this time is squared, divided by and moles per decimeters cubed squared again. Now this is quite simple because look, mole per decimeter squared, mole per decimeter squared, so I guess they cancel. Yeah, and what you're left with is moles per decimeter cubed. So therefore the units are moles per decimeters cubed. Okay, so there's that value, there's the units. Okay, so that's that question done. Next part, so part B. Let's turn this over. So part B, they're talking about state how the temperature should be changed at constant pressure to increase the equilibrium yield of C2F4. Equilibrium yield, yeah? So in other words, I want to increase that. Now, this is where the enthalpy comes in, which I didn't write down. The enthalpy was, what was it, 128? 128 kilojoules per mole. Whoops, 28 kilojoules per mole. Okay, so that's 128. So that means if going that way is positive, isn't it? So state how the temperature should be changed at constant pressure to increase the equilibrium. So I want to increase that. I know that if I increase, I'm just looking at the temperature here, so I know it's endothermic. So in other words, if I increase the temperature, this equilibrium will try and take in temperature. It will try and decrease the temperature by taking it in. And I want it to take in, and guess what? It's actually taking in that way. So in other words, if I increase the temperature, this equilibrium, the Chatelier principle, will move from left to right to try and take in temperature to reduce it again. Yeah, to oppose that change. So the answer to that question, I guess, is B, part 1. So if I increase the temperature, well, that's the answer. I increase the temperature and I'll get a greater yield of tetrafluoroethene. Okay, part 2. State how the total pressure should be changed. Oh, so now they're talking about pressure. Should be changed at constant temperature this time to increase. So constant temperature. So it's the pressure that we're looking for to increase the equilibrium yield of C2. So now they want you to increase the yield of that again, but this time they want to change the pressure. And so you should know that with equilibrium equations, you now, when you're talking about pressure, you need to look at the number of moles on either side. Okay, so the total number of moles on this side is 2 moles of that plus 1 mole of that. That's 3 moles and 2 moles of this. I want to increase this yield. That's what the question is asking. Yeah, to increase the yield. So I want to increase that yield again. So what am I going to do with the pressure? Okay, well, I know that there are more moles on this side. So that means, and there are less moles on this side. So if I increase the pressure, what's going to happen? It's going to try and reduce the pressure by reducing the number of moles. So it's going to go that way. It'll go from 3 to 2. 3 moles to 2 moles. If I increase the pressure, it's going to go that way. But if I decrease the pressure, this equilibrium will try and increase it. How can I increase it? By moving from left to right to give you more moles. And of course, that way it will give us more tetrafluoroethene. So that means I need to decrease the pressure, so I want it to increase it. Move that way. So the answer to that question is decrease the pressure. Okay, that needs a bit of thinking. Okay, so please make sure you don't make a mistake like that. C2, okay, so the final part is C2F4 is used to manufacture the polymer polytetrafluoroethene, PTFE. Polytetra, those people who do plumbing, they'll know this, yeah? PTFE. Okay, don't hold me to it, but I think some of these cooking utensils are actually, cooking pans, etc., are actually coated with PTFE as well. Okay, but certainly if you do plumbing, you know that tape that I used to do plumbing, yeah, home. That tape that you use to give a watertight seal before you start screwing on the nut, that tape, that stretchy tape, is actually the white tape, is actually PTFE tape. Okay. Anyway, name the type of polymerization. So the type of polymerization involved in the manufacture or formation of PTFE. Well, for that, you actually need to know what does that look like. Okay. If you don't know, go back to your probably GCSEs. All right. So C2. If you don't know, I don't know. So I'm gonna pretend I don't know. Of course I know. Yeah. But yeah. C2, so I'm going to try and draw it, see if I can work it out. Well, there are 4 fluorines, all right? So let me deliberately make a mistake. Okay, oh, 4th one is here. Okay, well, what goes on this carbon? Because each carbon should have 4 bonds, right? This carbon's only got 2, so what happens? Okay, I don't know. So that's obviously wrong. So I'm going to say, all right, no, let's do this. 2 on this. And 2 on this. Okay, well, again, this carbon's got 3 bonds, this carbon's got 3 bonds, they need to have 4. Well, the only thing I can do, I can't add any more atoms, there aren't any more. So the only thing I can do is put a double bond there. Tetrafluoroethene, there you go. Okay, and you know, any double bond, yeah, molecule, double bonded molecule that forms sort of a polymer is usually addition polymerization. Okay, how does it do it? They're not asking you to start explaining, yeah. However, I will, just so you know. What happens is you have 2 of these tetrafluoroethenes, right? One bond breaks from each one of these carbon-carbon bond breaks, one of them, and of course a new one is formed between the 2 molecule, and this one is ready to form with the next molecule. Here there's ready to form with the next molecule. Okay, so you get addition, so there's nothing being lost, etc. So this is addition polymerization. Marks. So obviously, you know, that's a mark here, that's a mark here. Right, so that's a mark, and write an expression for the Kc equilibrium. So 1, 2, 3, so that would be a mark. Okay, 1, 2, 3, so 1, 2, 3. Calculation, yeah, so that would be a mark there. 4, 5, and 6. So 4, 5, and actually 6. Okay, so that's 6 marks there, and then the rest of them is the other 3 marks are mark, mark, and this word mark. Okay. Common sort of mistakes I mean, some people get this wrong. It's not easy unless you practice it. Okay, so working out, they'll miss out the fact that there are, you know, the molar ratios. Yeah, it's not 0.8 and 0.8. So if it lost 0.8, it doesn't mean you get 0.8 of this and 0.8 of that. Okay, so it's actually ratio. So they forget the fact that these are ratios. So 2 of this gives you 2 of this, and 2 of this gives you 1 of this. So what they start doing is they start saying, oh well, 0.8 is lost, therefore it's 0.8 and 0.8. No, yeah, look at the ratios. Common mistakes, and yes, it is a common mistake. Sometimes people don't write square brackets. I'm not sure whether you'll lose marks. You probably will lose marks if you start drawing round brackets, but you know, draw square brackets. But certainly, if you miss out these squares here, you definitely will lose marks. Okay, that's why there's a separate mark for that. Common mistake again. You know, again, these are errors, yeah, the calculation errors, because students are in a rush. They try and sort of take shortcuts, yeah, and they start making calculation errors, yeah. So literally, they're trying to do everything. So 0.4 divided by 18.5 times by 0.8, yeah, divided by 18.5 squared. And so what's happening is on the calculator, 18.5 gets squared, nothing else. But anyway, so that's a problem. So please, if you know that you're not very good at this, do it separately, okay? This step and this step. Sig fig, I don't think you're going to lose marks because they've not mentioned significant figures. Unless you start giving less than 2 significant figures, you probably will lose marks. But other than that, you know, if you want to copy the whole calculator values down, you can. You won't lose a mark. You'll waste time, but you won't lose a mark. Yeah. These most estimates, I think once you've practiced this, the units are quite easy actually. Yeah. You know, to work out the units. But remember, units are different for every reaction for Kc. Yeah. So you got to work them out. Yeah, this needs thinking, this kind of question, right? So, you know, you've got to literally think about, okay, you know, there's the temperatures going down that way, so if I increase the temperature, it will go that. Yes, it needs a bit of thinking. Pressure, I think that this answer is incorrect more than this answer, yeah, in terms of pressure. Okay, so be careful with that. This one, as I say, you don't need to draw that. Addition, just remember, yeah, usually, as long as you know what that molecule is, if you know what that molecule is, a double bonded molecule, usually it's you know, addition polymerization. Okay. The other one they'll accept also is free radical. Yeah, free radical, if you remember, I've got another sort of video here, probably have a look. Free radical substitution. Yeah, so, you know, that's also accepted, but I never teach students free radical substitution, right? Because this is usually addition. That's the more common one. That's the more, you know, accepted answer. So, but they will accept free radical. Okay, but remember, double bonded molecules, when they join, it's addition. Okay, to make polymers. Okay, so 4 steps how to get these questions absolutely perfect. 1, remember the ICE method. 2, remember the moles ratios. 3, remember how to write Kc expressions, work them out, practice, and make sure you don't make any arithmetic errors, yeah, in the calculation on the calculator. 4 steps. Make sure you focus on them, work on them, practice on them, so you can get this question perfect. So, it's not a difficult question. Yeah, my suggestion is you must, as always, you must practice these questions. If you're weak at this, if you think, okay, I might not be able to answer it, my suggestion is just do this question. Yeah, you know, don't watch my video, have that, you know, in front, pause it at the start, and then just try it yourself, see if you get it right. And once you get it right, practice some more questions. Yeah, you must practice questions. I'm telling you, there's no 2 ways about it. If you want to get good grades, you must practice questions. Okay. Anyway, subscribe, please. Yeah, no options, subscribe. Like this video, share it, please, and leave a comment. Some of you have left a comment about, you know, my writing, you know, my worksheet's not sort of quite focused. I know, I am trying to work on it. This system that I've got, unfortunately, I'm working through the OBS, yeah. And if anyone actually knows what else to use, because what I've got is I've got a DSLR, yeah, which is connected to my computer, and I'm recording through OBS. And for some reason, going through OBS, you know, makes it sort of less focused, yeah, for some reason. But if anyone knows a better way of recording, let me know. I'd appreciate it. Okay, so don't forget, subscribe, please. I'll see you next Tuesday. Bye.